Hey stats class, we're going to talk in this video about correlation, what the concept of correlation is. So what I got here is some red dots that I can move around and some gray dots that you can see in the background. And I'm going to move the red dots over the gray dots and we'll see what the value of this correlation coefficient is. So correlation measures how linear a set of points are, how well a line describes what we're seeing. So I'm going to move these red dots into position over the black dots. They don't have to be perfect. And just pay attention to what that number is looking like. Alright, so that's almost 1, and it would be exactly 1 if I could get the red dots to be right in line where they're supposed to be. So when R is equal to 1, that's what we refer to as perfect positive correlation. And that means the points line up into a perfect linear relationship. The line that we're looking here explains the relationship between the x's and y's perfectly. Alright, I'm going to turn off the first data set, turn on the second data set, and remove these points around. So now the red points again are what we're measuring the correlation against. So you can see here that it's not a perfectly straight line, but there is this upward trend that is definitely apparent here. As we go from left to right, we do rise. It's just they don't stay on a line perfectly, the points I'm referring to. And you can see correlation is now not a perfect 1, but it's a number that rounds to 1. It's definitely higher than 50%. So now what we're seeing is R is going to have a continuous scale where 1 is the highest it can be, and the closer to 1 it is, the more linear the relationship. So as we make our way to 1, 1 being the highest it can be, the more linear it is. So does that imply the further we go to the left, the less linear it is? Well, for the most part, but look at this data set. So I would definitely not describe this as a perfectly straight line either, but now you can see R can be negative. And the reason R is negative is there does tend to be there is a predictive nature to this. Like as the x's are getting bigger, the y's seem to be getting smaller, but it's not a line doesn't do a great job at describing that relationship because we have so many that are kind of way off of this line. Like the predictive nature of the line is not that great. So the R value in absolute value is not that close to 1, but the actual sign is negative because if there is a trend here, it's a little bit downward. And by that we mean the x's on the left end are up high, and as you make your way to the right end, they're lower. But there's some that are kind of break off of that pattern, not perfectly, but this would be a much higher correlation if the one that had this y coordinate was way over here, and the one that had this y coordinate was way over here. Then we would have something with strong correlation, but in the negative direction. So what we now have, kind of building up to it, is R can cross over 0, and 1's the highest, and we can make our way towards 1 and have stronger and stronger correlation. But we can also now, we can see that we can go into the negatives. We can go in the opposite direction too, and talk about how well a line describes it with a negative number. Again, it being the pattern, the linear pattern of the data. Alright, do we have a lowest value R can be when we have negatives? Yes. So this is going to show us that R could also be as low as -1 when we have a perfectly straight line in the negative direction. So that's going to be our R scale. -1 is on the left side, +1 is on the right side, 0 is right dead in the center. And the further you go towards the -1 and the +1, the better a line describes what we're seeing. It's just the positive range is for positive slopes and the negative range is for negative slopes. So we have a perfect negative slope here, and we have R that's -1. Earlier we had a perfect positive sloping line describing what we're seeing when we were at +1. And then anything in between is something that a line describes less well than it is when it's -1 and +1. And the sign of the correlation coefficient would also be the sign of the slope. Alright, let's look at this last one. And here you can see that there's just no predictive nature of a line to these dots. You can see our correlation coefficient has 2 leading zeros before any number. So this is extremely close, approximately 0, which means a line just doesn't describe what we're seeing at all here. The line that we could draw in here would be roughly horizontal to predict a value, because again, sometimes we're seeing numbers, that low numbers, like with a small x matches to a small y, but then right beside it a small x matches to a large y. And then over here, a large x matches to a small y, but a large x also matches to a large y. And then the same goes in the middle. There's a relatively middle of the road x, a small y, middle of the road x, relatively large y. There's just no predictive nature to a line. And so a horizontal line would be our best guess, roughly. If that line is perfectly horizontal, then what we're basically seeing is the y coordinate. Remember, a horizontal line is y equals a number, and the y coordinate here would be the mean of the y values. I put a little line over top, just like x with the bar on top is the mean of the x's, a y with a bar on top is the mean of the y's. And that's our best guess. That's that horizontal line. We use these lines to predict. What do we think the y value is going to be if this is the x value? Well, if there's no predictive nature, we're just going to guess the mean. The average value of the y's, that's our best guess. But when we have a pretty strong correlation, which means a line does do a pretty good job at predicting what we're seeing. Now if I have a larger x value, I'm going to put x 2, and it's over to the right end of the range of the x's, that will match to a larger y. Then say an x1 over here will match to a smaller y. And so that line does a good job at helping us to predict values, because there is a correlation between x and y. So that correlation it's a measure of how well a line describes what we're seeing, and it also has to do with the tilt of that line. So when the line is very tilted, when there is a slant there, then the bigger the x, the larger the y, or possibly smaller if r is negative. But it makes it more predictable, the values that we're going to get, as opposed to when r is very small and there's just no predictive nature to the line. The line does a terrible job now at predicting what y coordinates are going to be for a given x coordinate. So again, we just use the mean. That's location of this horizontal line. It's the average y value is just being used to predict all the y values for any given x.